This video is going to look at some SAT problems that involve fractions that were pulled from either online practice tests or former exams. So remembering all our basic operations of fractions, adding and subtracting with the least common denominator, multiplying by the reciprocal when we're asked to divide, and also cross-multiplying fractions that are equal to each other, we can solve all these problems. So let's start here with number one. We have x minus 1 over 3 equals k, where k equals 3. So fortunately, they already gave me one of my values. I'm just going to go ahead and plug that in. And so instead of saying this equal to k, I'm going to set it equal to 3. Right? And more accurately, I'm going to set that equal to 3 over 1. So here I have two fractions that are equal to each other, which means I'm going to cross multiply. So x minus 1, I like to put it in parentheses just so I don't miss anything, times 1 equals 3 times 3, which happens to equal 9. X minus 1 just stays the same, so I get x equals 10 for number 1 here. Next problem, I notice I have subtraction and addition. So that tells me I need a common denominator. So I'm going to go ahead and I'm going to notice, okay, these two are already in a common denominator. I've got 9 and 9, so I can just treat this as 7 ninths minus 4 ninths, which would give me 3 ninths, which simplifies to 1/3, and then I'll tack on that x at the end. Since they both had x, I'll just worry about the x last. I can add it back on at the end. I just wanted to focus on the fractions first. So 7 ninths x minus 4 ninths x equals 1/3 x. The second half, however, needs a common denominator. So I'm going to take 1/4. I'm going to multiply the top and bottom by 3, so I get 3/12. Because then I can do 3/12 plus 5/12, which would lead me to saying that 1/3 x equals 8/12. I'm going to take it a step further and reduce my 8/12 to 2/3. Now the last step here, we notice again we have two fractions that are equal to one another. So I'm going to cross multiply. But before I do that, I should make sure I understand that this x is actually in my numerator, because it's actually x over 1. So I'm going to go ahead and just pop that into my numerator. I'm going to change 1/3 x into x over 3. Okay, whenever you have that x just kind of in the middle here, that really should be in the numerator. So I'm going to rewrite that as x over 3 equals 2/3. I cross multiply, so I'll get 3x equals 6 and x equals 2. Okay, and this is for number 2, x equals 2. Number 3 here, taking kind of a similar idea, they want to know what 4b over a is. And they tell me that a over b equals 2. Now, a lot of us will think, okay, I need to find a, I need to find b, and I need to plug them each in. But there's a shortcut here. Okay, there's a couple of things we can do. You might notice that this is b over a, and the other one is a over b. So what I can do with the original, or the first fraction they gave me, which is a over b equals 2, aka 2 over 1, I can flip both sides. Right? I can reciprocate both sides, so I can say that b over a equals 1/2. And then taking the second part, which is what they want me to solve for, if they want me to find 4 times b over a, well, I can just simply substitute that 1/2 in, so that I get 4 times 1/2. And 4 times 1/2 is the same thing as dividing by 2, so that just gives me 2. That's one option, if you can kind of notice the pattern there between the b and the a. The other option here is to cross multiply again. So I'm going to erase this, give us a little bit more space. And I'm going to start by rewriting this as a over b equals 2 over 1. And I'll cross multiply so that I'll get a, or 1a, equals 2b. And that 1 doesn't really matter, so I can just simply say a equals 2b. I can then use that and substitute it into what the equation they want me to solve. So 4b over a now equals 4b over 2b. Well, conveniently, my b's cancel out, And 4 divided by 2 is, once again, 2. So double check my answer, solve the problem 2 different ways. They both worked. Next problem here, kind of a similar idea, right? We have two fractions that are equal to each other, so I'm just going to start by setting this up and cross multiplying. I'll have 5 times x plus 20 equals 15x. I'll distribute into this, so I get 5x plus 100 equals 15x. Subtract 5x from both sides, so that I get 100 equals 10x. Divide both sides by 10. 100 divided by 10 is simply 10. Moving on, now we're going to get into kind of the medium difficulty level questions. Number 5 here, we have t plus 5 divided by t minus 5 equals 10. And I get in this habit of just putting it over 1. So I see, once again, I have two fractions equal to each other. I should cross multiply. Now, I mentioned this before, putting any kind of variable, any kind of x or y or t in this case in parentheses can be really helpful just so you don't forget to distribute. So now I'm going to have 10 times t minus 5 equals 1 times t plus 5. I'll then distribute, and the parentheses are kind of my cue there to make sure I distribute. So 10t minus 50 equals t plus 5. I will subtract t from both sides. So I get 9t minus 50 equals 5. And then I will actually add 50 to both sides. So that I get 9t equals 55. And at this point, you might think, well, this doesn't divide out evenly. T isn't going to be a whole number. That's totally fine, because if we divide both sides by 9, and these 9's cancel out, we get t equals 55 over 9, which is one of their answers. So if you feel like you're getting stuck because the answer isn't really coming out clean, per se, meaning it's not a whole number, don't freak out. Double check the multiple choice answers. Maybe they want a weird fraction like 55 over 9. Okay, next one, number 6 here. So some of you may have seen problems like this before on the SAT or ACT, where they give you this big description of, what is R, what is F, what is N. But we really don't need any of this information. Oops, sorry about that. Don't know what happened. But let's go back here. We really don't need any of this information. It's not going to help us solve the problem. What we just want to take a look at here is our multiple choice answers, and we notice they have F by themselves in all the answers. So what they want me to do is actually isolate for F, right? And I get that just by looking at the answer choices. That's all I need to focus on. So I'm going to rewrite my equation, and again, getting in that habit of putting any kind of whole number R over 1, so I can treat it as a fraction. And again, any kind of addition or subtraction with variables, I'm going to throw in parentheses. When fractions equal each other, we cross multiply. So I'm going to have R times n plus 5 equals F. And then I'm going to distribute. Remembering my goal here is to isolate for F. So I got F over here, but I got an extra one hanging out right there. So I got to figure out a way to get rid of that F. What I am going to do is I'm going to kind of free it from the parentheses by distributing the R into it. And then I'm going to actually want to group it to the other side. So I get Rn equals F minus Rf, just subtracting it to the other side, because this is the key step here. And hopefully some of you guys have noticed this. In order to get F truly by itself, I need to factor it out, right? And factoring is the opposite of distributing. So here where I distributed in, here I'm actually going to take F out. So if I take an F out, and taking it out or factoring out means dividing. Okay, so let's write that as a little quick note here. Factoring is the same thing as dividing. So if I take out an F, meaning if I divide an F, well, F divided by F is 1, and RF divided by F is just R. So that's me factoring out F to isolate it. And then the final step here, I'm just going to move it up a little bit. When I have Rn equals F times 1 minus R, the final step is just to fully isolate F by dividing by 1 minus R on both sides. And again, this answer is looking really weird, doesn't look like a normal answer, but if we just take a look at our multiple choice, we will notice that this happens to be answer choice B, right? Rn divided by 1 minus r.